Welcome to Homework Lib.
Hi. So for answering this question, we first need some information regarding the heat capacities of ice, water, and of course the enthalpy of fusion for our water system. So these values corresponds to the heat capacity of solid water, meaning of ice. It is going to be equal to zero point 0.5 calories per gram degree Celsius. The heat capacity corresponding to water as a liquid is equal to 1 calorie per gram per degree Celsius. And the final value that we're going to require is the enthalpy of fusion that has a value equal to 1.435 kilocalories per mole. Okay? So, in this case, the amount of mass that we are going to have is equal to 28 grams of water. Here we have two options. In the case for the enthalpy of fusion, here we have the value in kilocalories per mole. That is how it is provided most of the times, but we can convert that delta H of fusion into kilocalories per gram. How we can do it? Well, simply using a conversion factor that is going to look like this is kilocalories per 1 mole, and we know that 1 mole of water corresponds to 18 grams. Okay? So if we do this conversion, we can get the result, which is 0.08 kilocalories per gram. Okay, so that is one way. The other is to calculate the amount of mole. That is actually the preferred one because in that way we are not going to round up anything here. And the amount of mole that we have in our case is 28 grams of water divided by 18 grams per mole, that is the molecular weight of water, gives us 1.5555 mole of water. Okay, so now we want to heat up the water. We still need another value, that is the delta H of vaporization, because we want to start from minus 35 all the way to 185 degrees Celsius. So the heat of vaporization, luckily for us, I found the value directly in calories per gram. That is equal to 540 calories per gram. And actually, since that one is in calories per gram, let's go ahead and convert this directly into calories per gram, right? So in order to change the delta H of fusion, we need to add the conversion factor. 1000 calories correspond to 1 kilocalorie. And that is going to give us a more precise value of 79.722 calories per gram. Okay. And finally, we need the heat capacity of the vapor or of the gas, and that is equal to 0.477 calories per gram degree Celsius. Okay, so now we have all of the constants that we're going to require. Now, how do I know the total heat? First of all, we're going to have three different processes. First, we're going to change the temperature for the ice. So we're going to start at, remember this is final minus initial. I am only going to do the calculation for ice in this case. So this is going to be final. We want to get all the way to 0 degrees Celsius minus 35 degrees Celsius. So delta T for ice is going to be equal to 35 degrees Celsius. Next up, delta T of water liquid, it is going to be equal to 100 degrees Celsius because we want to go from 0 all the way to 100. And finally, delta T for water as gas, it's going to be equal to 85 degrees Celsius because we want to go from 100 to 185. Nice. So now the amount of heat that we're going to require is going to be equal to mass times heat capacity of ice times delta T for ice plus mass times delta H of fusion plus mass times heat capacity of water liquid times delta T for water as a liquid plus mass times delta H of vaporization plus m times heat capacity of water as a gas times delta T for the gas. Okay, so we can replace all of the values here. So 28 grams times heat capacity of ice, that is 0.5 calories per gram degree Celsius, times 35 degrees Celsius, that is the delta T for ice, plus 28 grams times delta H of fusion. We're going to use the value in calories per gram, so 79.722. This is calories per gram plus, again, mass, 28 grams. The water is still water. The mass is not going to change. That is going to be conserved. Times heat capacity of water, in this case, 1 calorie per gram degree Celsius. Times delta T for water, that is 100 degrees Celsius. Plus the amount of mass, 28 grams. Delta H of vaporization, that is 540 calories per gram. Plus, I'm going to put it down here, the final contribution, that is 28 grams times heat capacity of the gas, that is 0.477, times delta T for the gas, that is 85 degrees Celsius. Okay, so also to be consistent, calorie per gram degree Celsius. So over this, you can verify that every unit is going to cancel out. Gram with gram, degree Celsius, gram with gram with gram, degree Celsius. And we are going to end up with calories at the end. So the result of this operation, that looks quite big, is it's going to be 21,777.48 calories. And this corresponds to 21.777 kilocalories. And that would be all. Of course, if your professor provided you with different values for the constants, sometimes they differ a little bit depending on the units that they are using or the conversion factor, but they shouldn't differ by much from the constants that I provided here. Okay? And that would be all. Thank you very much.